Welcome to this video supplement on partial fraction decomposition. We're going to look at two examples. The first is on the screen right now. So what we need to do first and foremost is factor our denominator. Synthetic division, or perhaps if you see a quicker way to factor it, go ahead and employ that strategy. In this case, we're going to look for a 0 of x cubed minus 3x squared plus 4. So you could look through and figure out your possible rational zeros, and you could use that to try to determine how to find a 0 for this particular function. In this case, I'm just going to try some values out. Like if we plug in a -1, -1 cubed is a -1. This would be minus 3, which would be a -4. -4 plus 4 is 0, so I'm going to go ahead and do synthetic division. Now watch out because we're missing the x term, so we'll need a 0. Scoot the 1 down, multiply, add, multiply, add, multiply. There's our 0. That's our remainder. We're happy with that. We got our constant, our x, and our x squared. This would be x squared minus 4x plus 4. And I think that factors into x minus 2 times x minus 2. So when we factor our denominator, which is really the key thing that we need to do to start this off, factoring our denominator turns into x plus 1, because -1 was a 0, times x minus 2, the quantity squared. Now we set up our partial fraction decomposition with this expression. So we know that 2x squared plus 16x minus 13 all over x plus 1 times x minus 2 squared is going to split into something over x plus 1, something over x minus 2, and something over x minus 2, the quantity squared. We're going to put an a b, and a c. And then what we do is we multiply through by the entire denominator on the left, which is x plus 1 times x minus 2, the quantity squared. And that's going to get us a new equation that we're going to work with. So this is going to be a times x minus 2, quantity squared, plus b times x plus 1, x minus 2, plus c times just the x plus 1. Now what we want to do is plug in values of x that would be nice to evaluate. For example, -1 is a nice value of x to evaluate because the c is going to cancel and the b is going to cancel. So when we plug in -1 on the left, and now we can just take a minute and do that on our calculator, we're going to have 2 minus 16 minus 13, which is going to be a -27, it looks like. So a -27 is going to equal a times a -3 being squared. Remember, b and c disappear. This is nice. -27 equals 9a. So we immediately get the value of a. A is going to be a -3. That gives us one of the numerators for our partial fraction decomposition. Another value of x that's nice is x equals 2. So we'll plug 2 in on the left. 2 times 4 plus 16 times 2 minus 13 is going to be 27 again. That's kind of interesting. The a is going to disappear. The b is going to disappear. And when we plug in 2 over here, we're going to get 3c. So when we work this sucker out, 3c is equal to 27. C is equal to 9. And then we need to find the value of b. So we'll plug in another value of x. Now there isn't one that's obviously nice at this point, so I'm going to go with x equals 0. On the left-hand side, we get -13. On the right-hand side, don't forget we know what a is. A is -3. -2 squared would be 4. Plus b, oops, we don't know b yet, but we do know that we're plugging in 0, so this is going to be a 1 times a -2. And when we plug in 0 over here, we just get c, and we already know that c is 9. Simplify things up, we get -13 is a -12 minus 2b plus 9. So a -13 is going to be equal to a -3 minus 2b. -10 is equal to a -2b, so b is equal to 5. Now we go back to the expression that we had, a over x plus 1. So when we write this out, our original fraction, which was 2x squared plus 16x minus 13, all over x cubed, what was it, minus 3x squared plus 4 is equal to, on the right hand side it's our value of a, which is negative 3 over x plus 1, plus our value of b all over x minus 2, plus our value of c, which is 9, all over x minus 2, the quantity squared. And that's what we call our partial fraction decomposition. So what we have determined is the separate fractions that when combined together would give us what we want. Those separate fractions, when we make them combined together, are going to give us the expression that we had. So that's kind of a cool way to look at it, and that gives us the problem's answer that we needed. Now we are going to look at one more problem here, the problem that we see on our screen. This one is a little bit easier to factor the denominator quickly for those of us who maybe remember the grouping strategy right off the top of our brain. So if we remember the grouping strategy here, we can pull out an x squared, leaving us with an x plus 1, plus we've got a 1 times an x plus 1. So this is going to turn out to be x plus 1 times x squared plus 1. When we split this fraction into its partial fraction decomposition, it's going to be equal to something over x plus 1. Now we can't factor x squared plus 1 over the real numbers any more than that. So it's going to turn into a plus bx plus c all over x squared plus 1. We're making the numerator a degree smaller than the denominator. And then we multiply through by our denominator, get rid of it, and we're going to see what we're left with here. So 3x squared plus 10x minus 1 equals a times x squared plus 1 plus bx plus c times x plus 1. Again, we're solving for a, b, and c. First thing that I see that it would be nice is to plug in x equals negative 1. On the left-hand side, that's going to be 3 minus 10 minus 1, which gives us a negative 8. When we plug that in over on the right-hand side, we're going to get 2a plus a negative b plus c times 0. Ooh, that cancels. That doesn't even really matter. And we'll get that a is equal to a negative 4. Another value of x that would be nice is x equals 0. On the left, we get negative 1. We get a, which don't forget we know that a is negative 4, plus c, because b is gone, times 1. So as we solve that out, we're going to get that 3 is equal to c. And we just need one more value of x. Let's roll with x equals 1. 3 plus 10 is 13, minus 1 is 12, equals a, which we know is negative 4, times 2, plus b plus c, and I'm just plugging in x equals 1, times 2. But we also know the value of c, so let's plug that in there. C was equal to 3. And now as we reduce some things and simplify, we get 12 equals negative 8 plus 2b plus 6. So 12 equals a negative 2 plus 2b. 14 equals 2b, or b is equal to 7. So when we go to answer this question of what our final answer will be, we get the 3x squared plus 10x minus 1. And we'll write out this whole fraction, please. 3x squared plus 10x minus 1 all over x cubed plus x squared plus x plus 1 is equal to. Now our a, negative 4, goes over x plus 1 plus bx plus c all over the quantity of x squared plus 1. There's our partial fraction decomposition, and at this point we would have our answer. Now it doesn't matter what order you put things in over on the right hand side. You might write the x squared plus 1 denominator first, and you might have a different a, b, and c, but they should correspond to the same answer when all is said and done. Follow that technique and you know how to do a partial fraction decomposition.